I'm going to share my screen. Okay, everybody should be able to see my screen, my Chrome. And what you'll see in front of us is just the zyBooks. And we're going to talk tonight about Module 3, Decision Branching. So I'm just going to open this up right here. And basically, what we're talking about right now is how to make a decision in Python. Up till now, we have defined variables, we've done some calculations, we've input stuff, we've printed stuff out, but we haven't actually asked any questions. And that's what decisions in branching, if-else branches decisions are in Python. They're asking a question to Python in a manner in which Python can understand, and then acting upon the answer. Now, when I ask a question, I'll say, what's the color of the sky? And someone in the room can say blue, or gray, orange, whatever. And that, as an adult speaking English, that's the exchange I would expect. The exchange with Python is very different, and the exchange with almost all programming languages are very different. And that's because programming languages have only two answers they can possibly give, especially Python. Python can give you an answer of true or an answer of false. So you have to phrase your question to Python in a way that you're going to be able to act on true or act on false. And so that's what this module is about. It's about learning how to ask a question to Python so that you can get back an answer that you can act on. Given the fact that there's only two answers, true and false. And this is especially for people who've never coded before, this is kind of one of those sticking points. Once you get past it, a lot of stuff opens up. So we're going to spend a lot of time, and I'm going to spend a lot of time reading through the question and answer process while we go through this. And I'm also going to do that while we are going through our labs and our challenges. So let me bring this up. Let's see here. Hold on. Unshare. I'm going to unshare real quick. Should have brought that up. Okay, and is everybody on mute? If you're not on mute, could you please, I'm going to pause screen sharing for a second. Could you please put yourself on mute? Okay, thank you. Okay, let me go back to screen sharing. Okay. So we'll get back to that in a second. All right, a little disorganized. Here we go. So we have a couple of keywords that we're going to be learning in this module. The keywords are if, else, and elif, E-L-I-F. So those three are keywords. You can't ever use them for a variable name. They exist with specific actions that you can take in Python. So what do they do? If tells, let's see, okay, if tells Python that you're about to ask a question. Whenever you want to ask a question to Python, you start off with the word if. And Python will expect, after that, something called a Boolean expression. The Boolean expression is the question that we're asking that's going to give us an answer of true or false. And we call it a Boolean expression because we can only get two answers, true or false. So that's how that's how Python knows that we're about to ask a question. It's because we use the word if. And after that, you're going to ask it a question, and there's some syntax associated with that. Let me just show you. Let's do this first. I'm just going to do a simple if. Okay. So let's add the configuration. And then as soon as I hit the enter key, it'll tell me I need to configure the interpreter. Okay. So basically what I'm going to do right now is I'm going to ask a question to Python. So first I'm going to say my var is 10. I'm going to say if my var is equal to 10, or is the same as 10, print it's 10. Otherwise, could somebody please mute? Okay, I'll go out and mute for you. Okay, who's not muted? Okay. I guess everyone's muted now. Thank you very much. So I just wrote a quick script here. And I'm calling it simple if. And I created a variable myvar. I know it's a variable because it's on the left-hand side of a single equal sign. And the value I assigned it was 10, just because. Now I'm using this new keyword if. Here I say if myvar, and I've got two equal signs instead of one. The two equal signs check for equivalence. They say, is the value of myvar the same as 10? That's how you read that. So how I read this whole line is let me do this. If myvar is the same as the number 10, actually it's going to be, is myvar the same as the number 10? And the answer in this case will be true. At which point I'm going to print it's 10. Now, if that's not right, I'm going to fall into this else statement, and we'll talk about that in a second, and it's going to print it's not 10. So let's do something really quick here. Let's debug this. So I'm going to run this through the debugger so we can step and see what happens. So first of all, I have myvar is, I'm assigning 10 to the value myvar. I can see where it's done that right here. Now I am on line 4. So Python is going to evaluate, and it's going to say, is myvar the same as the number 10? If it is, it's going to print it's 10. And the program's going to end. Even though there are 2 more lines of code, it never hit them. It never hit them because else means else means, trying to do this without using the word if. Else means when the previous statement is true, you don't ever do what's in my code block. So there's another idea I just introduced, the concept of a code block, you'll notice here that the syntax is very specific, okay? I have an if, I have keyword if, I have a Boolean expression, and then I have this colon. That colon is very important. It's like us putting a question mark at the end of a sentence when we're writing it. So that tells Python to evaluate the expression. Okay, I'm done writing the expression, Python. Give me the answer, true or false. Then, when it gives me the answer of true, I come down to line 5, and I'm done. My console printout is 10, and that's it. The program in this case will stop because there's nothing after that is executable. If my var is not 10, then it's going to come down to line 7. So if I change my var to 11, and I debug this again, let's go step through it. So my var is 11. So is it true that my var is 10, or is it false that my var is 10? Well, my var is 11, so it is not true, which means it's false. And you'll see that I jumped to line 7. I didn't go down to line 5, and that's because my var wasn't 10. So this statement on line 4 evaluated false, and I then go and I am brought to line 7. And we'll go into this in a little bit detail. I just wanted to kind of give you an overview of what this decision and branching is, and what the syntax is, because we're also introducing the concept of a code block tonight. And a code block basically is some lines of code, 1 to n, however many lines they need to be, that is executed based on a decision, okay? And the block itself is indented 1 from the if statement or the else statement. So, and I'll show you what happens if you don't indent it in just a little bit. So let's go back here. Some of their participation activities are very helpful, so make sure to go through zyBooks and do them, because it will help you understand how branching works. And it's very important, because this is how we really get things done in Python. I use loops a lot. I use decisions all the time. Once you understand how to write a good statement, you can solve just about any problem when it comes to programming. These are just some more examples. Those are just some more. Okay, so come on. Sorry, my computer's a little slow. All right, so basically, under the if statement, there is a block of code. And there can be an else, there doesn't have to be. And that block of code is some series of statements that are only ever going to be executed when that code block is hit. So we talked about if-else statements. And the construct is you have the keyword if, the keyword else. You have an expression, which is your Boolean expression, and then the lines to be executed. I feel like I'm not explaining this as well as I could tonight. I apologize for that. Let's start by going through a challenge activity. Maybe that will help me get my mind a little bit better. So we're going to do 3.2.2. Hello, could you please mute your mic? Thank you. So for 3.2.2, it's write an expression that will cause the following code to print 18 or less. If the value of user is 18 or less, write only the expression. So what they've given you is everything other than the expression. So I'm just going to copy this. And there's going to be an input. We're going to write the age, and then it says your solution goes here. So what in the world should my solution be? Well, user age is the variable. And what I want to know is the user age 18 or less? So to do that, I know I have to have an if statement. And what am I checking? Well, 18 is the thing that I'm checking, and I'm checking user age against 18. So what I can do is, I'm just going to get rid of this. The question that I want to ask is the age of the user 18 or less? Which means I'm going to do less than or equal, and we'll go over the operators in a bit. So it's going to be user age less than or equal to 18. That's how you write that out. So user age with an input of whatever it is, and it says if the user's age is less than or equal to 18, is that true or is that false? Is the user age less than or equal to 18? That's a true or false statement. So let's go through this in the debugger. Let me change this. Okay. So I'm going to run this in the debugger. Okie dokie. All right, so it's waiting for an age. Let's say 29. Okay, so I thought I ran it in the debugger. Oh, I didn't have a, sorry. I did run it in the debugger. I didn't have a break state, a line break. So let's do this again. So I'm going to say 29. Now, we know from the debugger tab that user's age is 29. So if I'm just reading through this code, how do we do the debugger if you know, sorry, let me go back and read that again. Where's my chat? Why do we use the debugger if you know it's correct? Right now, I'm just using the debugger to show you guys how to use the debugger. I don't need to necessarily use the debugger right now, but I can guarantee you when you get into the projects for week 5, module 5, module 6, module 7, you're going to need to most likely run through the debugger when you have logic issues with your code. So we don't need to use the debugger right now. I'm using it as an opportunity to help get people familiar with the debugger. And it's also a good teaching tool to determine what to do with branches. No problem. So I'm on line 2, and line 2 is saying, is user age less than or equal to 18? Is that a true statement or a false statement? Well, because user age is 29, that's a false statement. Since it's false, the next thing it's going to hit is line 5. It's not going to hit line 3. So if I step over this, I go right to line 5, which is going to print over 18, which is what's printed out at the console. So if I debug this again, and I put in 17, on line 2, 17, well, is 17 less than or equal to 18? Well, yeah, 17 is less than or equal to 18. So I'm going to step in to the if statement block. It's going to get to line 3, and it's going to print 18 or less. And then it's not going to do anything anymore. And that's because else and if statements are mutually exclusive. They cannot both be run in the same code, okay? If it hits this if, it will never hit the else. Just simply won't. Python will skip over it. That's how it's built. Now there's a couple other things to look at here. Let's take the issue of a colon. That colon right there means something. And without that colon, if I tried to run this code, I would get this error, syntax error, invalid syntax. And it's kind of pointing to a blank space after 18. But it's not telling me that I'm missing a colon. It's just telling me that it is an invalid syntax. So when you're writing your code, if you get this invalid syntax and you're on an if statement or an else statement or an elif, which we're going to talk about in a few minutes, the first thing to do is look and see if you have that colon. Because if you don't have the colon, Python's going to throw up its hands. It's not going to know what to do. It's going to say, I'm sorry, I don't know what to do, so I'm just going to stop. And that's what it did right there. If I put the colon back in and I try and run it, it'll run. And everything is fine. Now, here's something else that is that can be confusing. On line 3, you will notice that it is tabbed in 1. It's tabbed in under the if, and that's important. That's how Python knows to only execute this print statement if user age is less than or equal to 18. But what happens if I forget to tab that in? Well, I'm just going to left justify it, so you'll notice on my screen that the I and the P are on the, in the same column of space. And if I run this, I get indentation error, expected and indented block. That means that after an if, just like after an else statement, Python is expecting a block of code. And the only way to denote a block of code to Python is to tab it in 1. Now, I can have multiple things in a block of code. I can have as many things inside a block of code as I want. However, well, let's just run this. Let's just do 23, and it's over 18. That's fine. But everything ran just fine. If I do it again, and I do 2, I get 18 or less and another statement. Now, if I mistakenly backspace that, let's see what would happen. I have a syntax error, invalid syntax on the else. Now, if I were looking at that line of code and only that line of code, I would say, hey, wait a minute, that else statement is fine. This is one of those issues where Python may not know where the issue really started, but it knows at the point where it hits that else statement that there's a problem, and that's when it's going to throw up its hands and stop. So the real issue is, if I look back, is this print statement. This print statement is not in a block of code. It is certainly not in the block of code for the if. And an else statement can only ever exist in association with an if. So what do? Well, that means that the print statement has to be as part of that block. Now, here's another thing that can be a little confusing sometimes, but I can put another print statement here. Let's just say the end. Now, line 8 is not part of any block of code, but it doesn't have to be. And it doesn't have to be because it is after the if, and in this case, it's also after the else. So if I run this again, and I'm going to do 3, and I have 18 or less, another statement, and the end. Now, I don't have to have line 8 there, but I just added it there as a demonstration. Now, when you do this, remember to not do line 8 and to not do line 4. So does anybody have any questions about this right now? Okay. Put them in the comments and let me know. Now, you don't have to have an else. You can have an if, you can have by itself, but you can't have an else by itself. So let's go back to our simple if. This is our simple if statement. Now, this is completely valid. If I run, let's change this. So, okay. So this is completely valid. If I run this, it's just not going to print anything because my var is 11 and not 10. Now I just added this thing called elif. Greater than 12. Okay. Okay, so I just added this thing called elif and this other thing called else. Well, this thing called else, which we knew. These are all what they call mutually exclusive. So that means if my var is 10, it will get to line 5 and it won't do line 6, it won't evaluate line 7, it won't evaluate line 8, and it won't evaluate line 9. It just won't. The next thing it will do is when it comes completely out of all the blocks. So this is completely acceptable for Python. You can have an if statement with no elif and no else statements. However, however, this is not valid, okay? You have to have an if statement. Syntax error, invalid syntax. That is because you cannot have an elif without an if statement. Additionally, you cannot have an else statement without an if statement. Again, syntax error, invalid syntax. You have to have an if statement before you have an elif or an if, or an else. So let's go back and And you can have as many if statements as you want or need. Nothing, you can only have, and you can have as many else statements as you want. You can only have one else. So that's something important to remember. Okay, equality and relationship operators, or relational operators. Equality is, are they the same? So that's the double equal sign. Double equal sign is not the same as a single equal sign. A single equal sign is assignment. It takes the value and puts it into the bucket that's the variable. Equality checks whether something is the same. And equality either is true or it's false. There is no gray area. They are either the same thing or they're not the same thing. So a double equal sign means, are they the same thing? So, excuse me please, an exclamation point before a single equal sign checks for inequality. It will say it is not equal to, or it's not the same as. And that's important because you can check inequality just like you can check equality. There are also what they call relational operators. Less than, greater than, less than or equal to, greater than or equal to. And I use these all the time. These operators are what most people use when they're writing code, because you're trying to compare something. And that's what these do. They allow you to compare them. You're not changing a value, you're comparing two values to see if you need to act on that, the similarity or the difference. Okay. Operator chaining. It's not something I do very often, but it is something that you can do. You can say A is less than B is less than C. That's something that's very valid, very valid. I tend to write longer hand code. There's nothing wrong with operator chaining. It's just not the way my brain works. And the interpreter will chain things properly if I need it to. Let's see. I want to go to Boolean operators and expressions. Okay, Boolean is the other type in Python. So a Boolean has a value of true or a value of false. The value of true is just that, it's true. The bit is switched on. Or false, which just means the bit is switched off. So it's 0 or 1. 1 and 0. I can't remember. And every expression comes down to true or false. Here is it's an important table to understand. And basically, it is what happens when you and or and not Boolean expressions. And this becomes important because when you start to look at compounding your expressions, you have to understand what's going to happen. So basically, the way I remember it is if there is a false, it's always false. When you're saying and, when you're saying this and that, if there is a false on one side of that and or the other, you will always come out false. The only way you can come out true is if there's true on each side. You have a true for expression 1 and a true for expression 2. If it's an or, it's very different. So if you're oring two statements, if both statements are false, then the entire thing is false. Otherwise, if any part of the statement is true, then the entire statement will evaluate to true. And not basically just switches it. So if it's not false, it's true, and not true is false. It may seem a little bit, it may seem a little odd, but once you start writing expressions, it makes a lot more sense. So we have these Boolean operators. We have and, or, and not. And means that you're saying however many expressions you have, you're going to and them together. You're going to and the results together. So well, let's do some examples. Simple and. So I'm going to say var1 is 1, var2 is 2, and var3 is 3. So I'm just going to do a simple statement to start. I'm going to say if var1 is 1, print it's 1. Okay? Very simple. We saw this before. If I run it, it's 1. But what if I want to check what's happening with var2 and var3? So if I say and var2 is 1, well, what do we think is going to happen here? Well, we know that var1 is going to be true. Is var1 the same as 1? Well, yes, it is. So that's going to evaluate to true. The second one is var1 the same as var2, the same as 1? Well, no, it's not. So that's going to evaluate to false. So I have true and I have false. So how do I figure out what the whole statement's going to be? Well, I have to look at what's between them. And because and is between them, if one part of the statement is false, the entire statement is false. So let's take a look, and nothing prints. So now what happens if I change this to an or? If var1 is the same as 1, or var2 is the same as 1, then I will print it's 1. And this time I print it. Now the only thing I changed was between an and an or. When you and things together, if there's one false in it, they'll all be false. If there's, so they all have to be true for the statement to be hit. If you're using an or, only one of them has to be true. So I'm going to go back here and I'm going to say and I'm going to say and var3 is 1. So now we know what's going to happen if I remember to put my colon there. I'm not going to get anything. Let's see what happens if I put an or here. If I put an or and then an and, it'll say it's 1. And that's because it says var1 is 1, yes. Or var2 is 1, and that's not false, and var3 is 1, and that's not false. And that's because right now we're dealing with the order of precedence for ands and ors. So that's something you want to absolutely look at. And I'm starting to go into this because we're going to deal with some challenges that and a lab that have compound statements. So, and then not. Not is just the opposite. So I could say, let's do this. I could say this. Whoops. Got to get it right. What would happen? Well, nothing different is going to happen because of the order of precedence. So let's say I change that to an and I make these nots. What do we think is going to happen? Well, it printed it out because 2, var 2, in fact, is not the same as 1, and var 3 is not the same as 1. So all of these evaluated to true. So really what you have to do when you're thinking about a compound statement is you have to take each part of that compound statement and figure out what in fact is happening for that part of the compound statement. And then go back and look at the Boolean operators in between the compound statements to figure out what's happening. And your debugger can come in very handy when you're doing this. Okay, so an expression in Boolean operators is print special number if the special num is -99, 0, or 44. That's very simple. Sorry, that's very similar to the simple AND we just did. So let's go membership and identity operators. So these are some more special operators that you have. In and not in. Now these specifically deal with lists. And they're very handy and we will use them when we get farther into lists. So, but for right now, just know that they're there. So in this case, the in just says, is it contained in a list? That's all it is. And it makes it very, very easy so you don't have to run through the list. But we will deal with those more later, and I don't think there's even a challenge with that. The identity operator is and is not. This is based on an object-oriented nature of some parts of Python, and is just says, are they the exact same object? What that means is, do they, if you have an object, does that object reference point to the same place in memory for both of the objects? Because you maybe named that memory space, and this can only happen with objects. You may have named that memory space one thing at one point and another thing at another point, and you want to make sure that they're the same. You don't need to worry about that at this point. Later on in the class, we will be doing that. Now for this challenge activity, it's write an expression using membership operators that prints special number if it's in the list. So instead of, the only thing you have to deal with here is using that in operator. So it would be if num in special list, then you do this or you don't. Order of evaluation. This becomes important because there is an order of precedence that deal with both arithmetic, logical, and relational operators. Parentheses are always first. Then the arithmetic operators use their order of precedence, which is in an earlier section. Relational operators and membership operators are second. And then you have not, and then you have and then you have or. So when you're writing large compound statements, it's always good to know what your order of precedence is. For the most part, in this section, you're not really going to have to worry about order of precedence that much. If things aren't behaving the way you think they ought to, then come back to this table and look at the order of precedence, and also go through the debugger, because it will be very helpful. So I'm going to try, let's see, code blocks and indentation. Code blocks and indentation is very important. This is a point in time where students start to pull their hair out. And it's because they don't understand why something isn't working, and they don't understand why they're not getting the right results. They've got an if statement, but not everything's happening. So why is that? Well, because of this. Okay, so if I run this as it is, I'm going to get it's one and another line of code. Let's just change this here and here so we don't necessarily always get to that. Now, the only thing I've done is change the not equal to the equals, and I run it and I get another line of code. But what if I don't want to print another line of code? Maybe I only ever want to print another line of code if this expression, that whole thing, evaluates to true. Right now, it's always printing line 8, and that is because line 8 is not considered part of the if block. The if block consists right now of a single line, and that's line 6. And I know that because line 6 is the only line that is indented under the if statement. If I wanted line 8 to be part of that if block, I need to tab. And then if I run it, I don't get anything for the output. That's because it is tabbed in, and this is all part of a block of code that will only be run assuming that the if statement evaluates to true. So let me do that again. Line 8 will always get run at this point. It will always be run because it is not indented, therefore it is not part of that if block. So we see that it printed down here. If I want line 8 to be part of that if block, I have to indent it 1. That means it's part of the code block that will only be executed if this statement, if this entire statement evaluates to true. And it evaluated to false, so I don't get that line of code printing out. Those are best practices. Conditional expressions. Okay. Let's see. A conditional expression has the following form. If condition, I don't use these. I don't know anybody who writes code using these conditional expressions. I'm not really worried about you using them if you're in my class especially. They don't do anything specifically to help with, they don't do anything to necessarily help make the code more readable. So I don't use them. You go ahead and use them if you want. They are valid syntax. But I don't use them, so I'm not going to spend a lot of time on them. Okay, so this is just some additional practice, and we're going to talk through some of these labs, and then I will do a little bit more with the third lab. So in this lab, and I'll just get you guys started. Python file. So 3.13, 3.11. Okay. All right, so let's just talk about this for a minute, and then I'll get you started and write up some comments that might help get you through this one. So basically, this is write a program whose inputs are 3 integers and whose output is the smallest of the 3 values. So we're going to take a single input, and we only want to output if it's we only want to output the smallest. And so there's a couple ways we can do that. One of those ways is that you could split this into a list and then use the in operator. Whose inputs are 3 integers. Or, so we'll just do it with 2 integers. We'll do var1 and then var2 So in this case, I would say if var1 is less than var2, which means it's smaller, then I would print var1. Else, I would print var2. Now, this doesn't get you all the way to the answer, because what we don't have here is we have a var3. So we still need to define and we also need to do the check, because right now I've only got 2 checks. I've got var1 and var2. So now we're going to have to use an elif to check whether or not var2 is less than var3 and var1 is less than var3. So there's a couple of other checks that you have to do here. So this is only part of the way, and you need to go through and figure out how to do it for more than just 2 variables. If we run this one through, if we run this one through just as a test, I'm going to put in 1 and 2, and it's going to print out 1. So now how do you go about doing this for one more variable? And now you have to make sure that you're checking all of the variables against the other variables to make sure that you're getting the smallest one. Okay, seasons. So write a program that takes a date as input and outputs the date season. The input is a string to represent the month and an int to represent the day. So this one is a little bit of a longer program, but it is very doable. So you're going to input a month and you're going to input a day. And based on these date ranges, you're going to output the season. So spring, summer, autumn, winter. You also have to make sure that the input information is valid. There is no month called chair. So you're going to have to make sure that the months that someone is only putting in the months that you expect them to put in, and someone is only putting in the dates that you expect them to put in. So they can't put in the number 65. There is no day 65 in the month of March, even though sometimes it feels like the month is that long. So those are some things to look at when you're doing this, and there will be a lot of if statements. There's going to be a lot of if and elif statements in this particular challenge, in this particular lab. Give yourself some time and start by taking baby steps. Now, what in the world do I mean by baby steps? Well, let me just show you. So let's take this, and we're going to, again, get started. Oops, come on. This is lab 3.12. So let's just get started. So I'm going to say month equals input, day equals input. Okay? The first thing you're going to have to do is validate. And I'll let you guys do the validation. Then I now need to figure out, assuming everything validates, where am I? Am I in spring? Am I in summer? Am I in winter? Am I in fall? So the first thing I'm going to look at is probably the month. So I'm going to say if month is the same as September, and let's see, what do we have? Let's see, September 22nd is autumn. Before the 22nd is summer, and the 22nd and after is autumn. So I would simply say something like, and day is greater than 21, print autumn. Okay? So I could then say elif month is September. If I can spell. And day is less than or equal to 21. I'm going to print summer. So this is an example of what you would do. I would do elif month October, print. So this is an example of what you would do for this particular lab. And it's going to be an if and lots of else statements. Okay? Very similar to what you just see me do. So this is just the starting place. And for validation, what you want to do is you basically want to say if month not equals January, if I can spell, and month not equal February, and month is not equal to March, then you would just say print invalid. Okay? Then, and you would end the program at that point. You'd just be done. And then you would want to check the dates as well. And then you would come down here and figure out whether things were spring, summer, winter, or fall. So that's the beginnings of 3.12, and now I will get on to the one that Jake wanted, which is 3.13. The exact change lab is a little bit of a, it's a little confusing when you first look at it. So what you want to do is write a program with the total change amount as an integer input and output the change using the fewest coins. So 1 coin per line. The coin types are dollars, quarters, dimes, nickels, and pennies. Use singular and plural coin names as appropriate, like 1 penny versus 2 pennies. So this uses the floor operator, and it uses if statements. So let's just do this. So I'm just going to say coins is going to be some input. So I want to know how many dollars. Let's just start with dollars. So I want to know how many dollars are in the coins, because you're always going to have to start at the largest and move down. So what I'm going to do is I'm going to say dollars is going to be coins. What's the operator? 100. Is that right? I almost never use the floor operator. It's so bad. Okay. And that will give me the number of dollars. And now I'm going to say coins. Coins minus left, L-E-F-T. I can spell. And then I would do it. So now I have the number of dollars, and I would say if dollars is greater than 1, then I would print, what do they want the output to be? I would print 1/4. Okay. I would print otherwise, there's my else statement, I would print so, and that would be how I would take care of dollars. And then I would do the same thing for quarters. And I would do the same thing for nickels. So I've got this coins left. So then I would use coins left to do the same calculation but for quarters. And is this really right? If it's greater than 1, else, do I want an else if here? Because what if dollars is 0? So think about that to determine if you actually need an else here or an L if. Because what if dollars is 0? So does anybody have any questions about that? Hopefully I've done a little bit better to make things as clear as mud tonight. Okay, so if nobody has any questions, I am going to call it, and please reach out to your professors. If you're in my class, as always, just send me an email if you have any questions, and I'll do the best I can to help. And this will be up probably tomorrow for my class, and hopefully not long after for instructors in other classes. So good night. I hope everyone has a good evening. Thanks for attending.